Okay, everyone. To use this?
Yeah, use the microphone. Yeah.
Okay.
Record.
So, hi, my name is Dave. I'm here to give a little intro to Nix or Nix OS. So, who of you is a software engineer? Okay, quite a few. Cool. Who of you have heard about Nix or Nix OS before? Okay. Wow. Okay. Cool. Just for the people who don't know Nix, it's not my project. I just like using it. I'm one of many contributors to the Nix ecosystem. Just thought, because there's lots of software engineers here, it might be interesting to talk about it. So I think Nix is amazing. It can give you superpowers as a developer, and I want to show you why today. Okay, so why do I use Nix? I use Nix because it gives me control over all the software components that are on my computer, and also gives me control over all the software components that I build on top of as a developer, which is important for me. It's a holistic approach to managing software in general. It doesn't really matter if you build a program or a developer environment or an operating system. You always have control over the full stack, right? Especially if you build an operating system. So you can also customize all the components that are involved, all of your dependencies, whatever you're building. And it is a great tool that gives you good reproducibility. So that means if I invested some time into something and I've made it work, it doesn't matter how complex it is, it will keep working. It will not break apart anymore because of some random involuntary update or something like that. Stuff keeps working, so it saves me a lot of time, and I think it makes me more productive in the end. So how do I use Nix exactly? So I use Nix for most of my development environments. If it's a private project or a customer's project or whatever, open source project, I like to manage my development environment with Nix. Before I've been using Docker, which is fine as well, but since I started using Nix, I have a lot more fun managing my environments. Also, Nix is a great tool for running in your CI pipeline because you just have a very good guarantee that whatever happens on your machine is going to be exactly the same as happening on your CI pipeline. So it ensures that, like, if it breaks in my machine, it breaks at the CI and vice versa, which is great. Also, I use Nix to share my projects with other people. So whenever I publish something, I always put a bunch of Nix files in there, and that ensures that everybody can very easily run my projects. It doesn't really matter how complex they are, because it's in the definition of this Nix code how all the dependencies are built and so on and so forth, and how it's run. So I don't need to write a lot of readmes on how to set this up and how to set this compiler up and whatever it needs to be done. It's just automated. So it makes it easy for other people to use my software. I also use Nix to manage my own computer. That approach is called Nix OS, right? You use the Nix tool to basically define an operating system. That's quite nice because, for example, my laptop is pretty broken already. I'm probably going to get a new one soon. And if I get a new one, it will be very easy for me to switch to the new system, because I have everything defined in Nix, and I will just apply this configuration to my new machine, and my new machine will look and feel and behave exactly the same as the old machine. I don't need to download things, install things, update things, configure things. It's all done. Okay, so what are the general properties of Nix? So Nix is a declarative approach. Some of you may know this from tools like Terraform or Ansible. But Nix is declarative in a much more fundamental way that gives you much better properties like reproducibility and so on, whereas most of those other tools, they just build on top of something that's not super declarative and they break from time to time. So any change that you make on things that are defined in Nix, they are atomic. So it's like a database transaction, basically. So if whatever I change, it doesn't work for some reason, or there's a problem with my definition, I will not end up in a half-broken system. Either my change applies or it does not apply. So my system is always in a consistent state, I never need to reinstall my system because it got a little bit messy over the years. That doesn't happen with Nix, because any change I do on my NixOS is the result afterwards is as if this system was just freshly installed with the configuration. So the state doesn't degrade over time. And because everything is well defined and atomic, I can easily roll back whenever I do something. Maybe I misconfigured something, maybe I broke something, maybe something doesn't behave the way I want it. I can always just roll back to the previous state very easily. Okay, what are some more applications of Nix? Nix is generally a great tool to access all kinds of open source software because, as I will show you in the next slide, there's like a large collection of software packages that are already packaged with Nix. You don't have to do it yourself, and you can just access them. This is a great entry to open source software, and it's very good for supply chain security because if you use Nix, you have very good understanding of all your dependencies. You can generate SBOMs and so on. It's a nice tool to manage your own infrastructure or a company's infrastructure. It's generally great for scalability because everything that's reproducible is very good for scalability. If it works, it will continue working, and it will also work on another machine. So you can scale up things pretty nicely without having stuff breaking all the time. It's a great tool to publish computational experiments because right now it's often a problem if people write paper, maybe they have some computational experiments that 5 years later somebody's looking at that paper, they want to verify that experiment and they can't because however they delivered it, it's not holistic. It doesn't define everything that's needed to run that, and stuff does change quite frequently in the software world. So stuff usually breaks after a couple of years. With Nix that doesn't happen, and Nix achieves true infrastructure as code, which is great. You can build Docker images with it. You can build SD card images for your Raspberry Pis. You can build USB stick images, whatever. All these kind of things. And generally, I think Nix gives you peace of mind because you know once you build something once and it works, you tried it, it works, it will keep working, which is great. So what exactly is Nix technically? So Nix is just a tool. It's a C++ tool. I could build it and statically link it and send it to you. It would be a 20 megabit binary, and this together, the Nix code that I've written in the Nix language allows you to reproduce anything that I ever did on my computer on your computer. And then the core value of the whole ecosystem basically are the Nix recipes that are maintained by the community, which are hosted in this mono repo Nix packages. So there's like around 80 to 100,000 software packages which are defined in Nix. And that definition contains also the information how to build them and how to build those dependencies. So usually whenever you interact with Nix, you're always in some way accessing this mono repo and are building something based on those definitions there, or maybe you can modify them a little bit. So in the end, Nix is a great tool to use for package management. Not just that, but it is a great package manager because of its properties. So yeah, this mono repo of all the package definitions I was just talking about here, some stats about it. Can I zoom out? Yeah, anyways. So it's a bit cut off. So this is a graph showing the Nix packages software repository compared to other software ecosystems. For example, the one of Ubuntu, or the one of Debian, or the one of Arch Linux. And the x-axis is the amount of total packages, and the y-axis is the amount of up-to-date packages. And you can see that those are all different versions of Nix packages, except that is Arch user repo. But you can see that, the main version that everybody contributes to Nix packages on stable is way up there. So in these metrics, it outperforms any other package ecosystem that's out there currently. Even ones like Ubuntu or Debian is even lower down here somewhere. So this is maintained by several thousand contributors. That's why it works well. Yeah, so I think I will jump into a demo and show a few examples. But you can also ask questions, maybe then I can adjust the demo a little bit to your questions. Do you have any questions? Yes, please.
How hard it is to manage configurations of GUI applications where you configure it through the GUI?
I'm not sure exactly what aspect you mean. I mean, how will you, okay, so in order to configure something with Nix, it usually, there needs, like the software that you're configuring needs to have some kind of configuration interface, right? If it doesn't have that, then it's more difficult. For example, if you want to manage all your settings in Firefox, I think there's like an add-on that you can that you can do that with, but like you would have to set that up. I didn't do that for sure. Somebody wrote a Nixos module to do that. I know other people do it. I just don't care so much. So yeah, but so it's a matter of integration, not necessarily every single option that a program.
So for example, right now, you are not managing your Firefox configuration?
I don't manage my Firefox configuration right now, yeah. Okay, any other questions?
How often do you come into a case where the Nix program, or the program that you want to install is not in the Nix package, and it's like another package?
I mean, it happens every now and then that something that I need is not in Nix packages, but what I usually do is then I create a Nix package for it. Like I package it, which is like kind of what you're doing anyways. Like if you interact with Nix, sooner or later you're gonna have to learn the Nix language a little bit. You can do it in the command line, try out some things, but as soon as you want to customize stuff, what you're essentially doing is modifying an existing package. So that's the same language as just creating a new package. I mean, there's like different frameworks in this Nix packages, monorepo for Rust, for Node.js, whatever. Some of them, they are capable just reading in log files and generating your Nix package and stuff like that. Sometimes you have to do some packaging work. It's usually, of course, I can install other package managers as well, but then I lose lots of these guarantees, and I want to share my environments with my colleagues, and so I prefer doing it with Nix if it's possible. Okay, any more questions? Cool, then I just showed some examples. Okay. So yeah, I just want to run you through some basic things you can do with Nix, yeah, I will show you how to do a development environment, like one that's temporary, where you can just play around with a few tools, and then one that's declarative, which is nice for sharing. I will show you how to do customizations. For example, if you do something, I have an example for machine learning where maybe you have an Intel CPU and you want to rebuild that library that optimized for that specific CPU. And then I will show you how to build an operating system, and if we get to it, maybe also how to build an image for a Raspberry Pi. Okay, so by the way, you can try this yourself. What I'm doing now, this is a service that's hosted by a friend of mine who did a similar talk. And basically, if you SSH into that URL, then you will have an ephemeral Nixos VM which you can play around with. It has Nix installed, and you can try out the thing. The password is I hate Nix. Yeah, and if you want to, I'm just touching things very, very briefly here because we need to get on to the next talk. But if you want to have a more extended talk, you want to listen to a more extended talk about this in more detail, then I can really recommend this talk of my friend Matthew Program. All right, so let's jump into it. I cannot copy here, can I? Okay, so let's SSH into that machine. I hate Nix. Okay, so now it boots a virtual Nixos machine. By the way, you don't have to run NixOS in order to use Nix. You can just install a Nix package manager, but maybe this is just easier, just to play around with it for most of you. Log into this SSH machine. Okay, so anyway, so what can I do? For example, let's make a little development environment. I want to declare a development environment with Nix. So I'm creating a little file that's called shell.nix. Oh, and I don't have Vim, so we can get Vim using Nix. You can just say, give me Vim. So now basically now Nix looks into this definition of Vim in this Nix packages monorepo. It figures out that, oh, those are all the dependencies of it. And then it checks, oh, are these dependencies cached? Can I just download the binary or do I need to build it myself? And now it figured out, okay, all of these dependencies are on the community cache, just download them. If the cache would be available, it could just build all of the dependencies of Vim from source, no problem. So okay, let's write a little development environment. So first I have to import this Nix packages monorepo. And then the monorepo not only offers packages but also functions to like combine stuff together, and one of them is called mkshell. And it takes packages, a list of packages, and then maybe I want Vim in this environment, and I also want hello in this environment, and I also want Python 3 in this environment. So yeah, that should work. So now I can call this definition of a development environment using Nix tool or Nix shell. Well, actually, I should exit my current environment first. So now I'm out of the temporary environment. I don't have Vim anymore, right? But now I can call this definition with Nix shell. Now it evaluates it. It needs to figure out, is there anything it needs to build from source? Is there anything it can download? Okay, it found everything, it downloaded everything. So now I have Vim. Now I have hello, and now I have also Python 3.
You should use NeoVim.
Sorry?
You should use NeoVim instead.
Maybe. Okay. So anyways, yeah, feel free to play around with this. I think I will switch back to my own system for the other examples because it's just a little bit quicker. Using VS Code. Okay. So what are some other examples? So for example, if I want to have a Python, so that was the thing that we just did, right? Just have a few packages in an environment. I can also do something more complex. I can say, oh, I want Python in an environment, and I don't want just Python. I want Python with packages. So that's basically a function of this Nix packages framework that I can call, and I say, okay, I want Python with PyTorch. Okay, so now it's generating a Python environment for me that has Python and PyTorch. I can also do something more complex than that. For example, let's say I'm not happy with the default version of PyTorch because I don't have a GPU on my laptop. I have an Intel CPU, and I want to use Intel MKL as a basic linear algebra subprogram library, which is more efficient on the Intel CPU. All right, so I can do that. Usually, So basically, I can define a modification of the PyTorch that's in Nix packages using these override address modifier function, and I can say, so for the class library, use the Intel MKL library, and then I define a Python environment with my custom torch, and then I put this into my shell. So, and what happens now is that Nix is going to rebuild torch with support for MKL. So if I just do that, it's probably cached on my computer because I did this today before. So probably don't build anything right now, but I can run it onto an empty Nix store, and you can see how it behaves. Oh no, it actually does build something. Okay, so now it's figured out. Okay, the torch version, the torch with this configuration is not available on the community cache, so it can't download a binary. And now it starts building it from source. The great thing is because how it's built is defined in this Nix code from the community. I don't need to set up a build environment for torch or anything. Like it will just do that automatically. I just need to set the flags, and it will rebuild it, and it will work. I don't have to spend hours and trying to understand their build environment. Okay, so that will probably go on for a very long time now. I will skip it, I will cancel it. Okay, so another thing that we can do is not just building an environment, but building a whole operating system with Nix. And here in the Nixos directory, I have a NixOS configuration. It's also just some Nix code. This one is fairly minimal. I just have some settings for my user. So, I also enable an Ethereum node here. But then I just set up my SSH key so I can log into this machine. And then I can wrap this with some other Nix code that allows me to build an image. Like this is basically, I could flash this onto a USB stick or anything, and then just boot a machine. But I have a virtual machine, so let's just start it. Anyways, yeah, I think I'll have to wrap it up. So you got an idea. You got an idea about how everything works. I'm sorry, I was too slow. So yeah. Anyways, if you have any questions about it, just approach me and ask me about it. Just Google Nix or NixOS in case you're interested in learning more. Great resource is nix.dev, which is a really great entry point for Nix. Well, my screen stopped working, I guess that's it. All right. Any more questions?